So we're going to simplify some logarithms without a calculator. So when we see log, this is red, log base 4 of 16. This is asking you, this log here is asking you 4, so this is the base here, 4 to what power, what exponent would make it equal 16? So we know that 4 times 4 is 16, so it equals 2. So this one here, this is saying 3 to what power equals 81. So we know that 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So it takes 4 of them to multiply to 81. So we would get 4. Okay, this one doesn't have a base written, so we know it's an implied 10. So we have 10 to what power equals 100. So we know that 10 times 10 is 100. So it takes 2. Okay, so we have 5 to what power is 1 over 25. So I know that 5 times 5 is 25. But since it's in the denominator, to move those 5 times 5 to the denominator, we need a negative exponent. So we're going to get negative 2. So it took 2 5s to make 25, and then we need this negative so that it sends it to the denominator here. So we have 1/2 to what power equals 8. So I know that 2 times 2 times 2 is 8, but it would mean that it would look like this, 1/2 times 1/2 times 1/2. If I put a 3 here, that's what it's saying, which is 1/8, not 8. So if I want this 8 to be brought up, so it's 8, I would need this exponent to be negative 3. So the answer is negative 3. Okay, here we have 4 to what power equals negative 16. So I know 4 times 4 is 16. So there's no way to get negative 16. There's no way. There's no exponent. If I make the exponent negative 2, if I had 4 and I made the exponent here negative 2, that's going to equal 4 times 4, but in the denominator. So there's no way to get this negative 16 here, so we call that undefined. Not possible. Okay, here we have 5 to what power is 5? So 5 to the first power. We also learned a property that when these two are the same, they essentially cancel out and just make 1. Okay, here we have 4 to what power is 1. So we've learned that 4 to the 0 power, any x or base to the 0 power is always 1. So this is going to equal 0.